All right, so we're talking about average atomic mass, and we're also going to talk about, zoom in here, also talking about molar mass and mole calcs. And I'm pretty sure we have empirical. Oh no, that's tomorrow. Yeah, that's tomorrow. Anyway, so average atomic mass, mole calcs, and molar mass. I'm gonna make us a little side note here, just in case we don't remember what all this is. So remember average atomic mass. Basically what that is what we use to find, or what we use that's listed as the weights on the periodic table. Okay, because every element has isotopes. Isotopes have different numbers of neutrons, and what happens is the mass of all those isotopes is averaged based on the percent abundance in nature of that isotope, and the average atomic mass is what's used on the periodic table. So we do have a formula for that, average atomic mass. Okay, this thing is a sigma, and I'm pretty sure that's the best sigma I've ever drawn in my whole life. Okay, and so sigma means sum. All right, and basically it's the sum of the mass of the isotope times the percent abundance of that isotope. Okay, and you do that for every isotope. Okay, so that's just a little refresh on average atomic mass. And okay, so let's do a problem. So over here we have neon as an isotope. We have our relative mass of each isotope because we have neon 20, 21, and 22. Okay, we also have their percent abundance in nature. So let me draw this little table. Okay, so we need to find the average atomic mass of neon. So yeah, we could just go and look at the periodic table, but we're going to know how to math it. Okay, these percents are going to change to a decimal in that equation that we just talked about. So then when we go through, we have 19.992 times, and this is, we change that percent to a decimal, so 9092. Okay, and we're adding it to 20.994, and this is now a percent or a decimal as well. Okay, and these are multiplied by each other, so we multiply each one and then we'll add all of it together. So this is a plus sign. And this last one, we have 21.991 times 0.082, or 882. Okay, so I will give you a little hint when we do this, that whichever one has the biggest abundance, which is neon 20, is going to be which one the average atomic mass is closest to. So when I do all this, I multiply here, multiply, multiply, and then add up each of those numbers. I get 20.656 U. Okay, and the U is kind of special. It can mean a bunch of different things. It can mean AMU. It can mean, an AMU is atomic mass unit. which is just grams per mole. Okay, so it's what we get on the periodic table, which makes sense because the average atomic mass is what's on the periodic table. Okay, and this is closest to, we got 20, and that was our biggest percent abundance. So that's that one. That's all you had to do. This one's a little bit different. 2 isotopes of chlorine exist in nature. 75.77% of chlorine is chlorine 35, and it has a mass of 34.96885 AMU, and they want to know the mass of the other isotope. Well, I don't even know what the other isotope is. I know there's 2 though, and I know that percents add up to 100, so I can do 100 minus 75.77%, and that will give me the percent abundance of the other isotope. So when I do this, I have 24.23%. Okay, and that's isotope, oh no, wait, undo. This is isotope number 2. Okay, so next what I can do is I can set up the equation just like I had. I know that the average atomic mass of chlorine is on the periodic table. So when I look at the periodic table, I have 35.453. Okay, so that's what my total is. That's what I should get in the end. And then I can set up my math. So I know the percent of chlorine 35, like percent abundance, and then I know the mass. So I can go ahead and set that up. So I have 34.96885 times, and I had to change this to a decimal. Okay, and that's going to get multiplied before we do this other part. So I don't know the mass of the other isotope, but I do know the percent abundance. So what do we do for things we don't know? We just plug in an x. Okay, and 0.2423. Okay, and so I do all my math greatness. And then I have x equals 36.967 U. Okay, so this is the mass, the other isotope of the other isotope, which is, oh gosh, I'm so ugly, 37. Okay, not too terrible. So whenever there's something you don't know, just plug in an x. Okay, so now our favorite thing, the mole. Okay, these are going to be one step, just so you know. So before we can even talk about the mole, we do need to talk about molar mass, okay, or otherwise known as formula mass. Okay, this can be called so many different things, and that's all in this paragraph here. So what do we have? We have gram formula mass, molecular mass, gram molecular mass, formula weight, gram formula weight, molecular weight, gram molecular weight, molar mass, that's what we call it, and molar weight. Okay, so that's the mass of 1 mole of a compound, atom, or ion. So what they want you to do right here is find the mass of each of the following. So we're just going to do this off the top of my head. Sodium is like 24, chlorine is 35. So together, that's going to give you 59 grams per mole. Okay, arsenic trichloride. So let's write that formula out. Okay, and I don't know the math of arsenic off the top of my head, but I do just go ahead and have this written down. So again, what I'm doing is I'm taking the mass of arsenic, and then I have 3 chlorines. So I know chlorine's 35, and I multiply it by 3, and then add it to the mass of arsenic, which gives me 183 grams per mole. Okay, potassium sulfate. Okay, potassium has a +1 charge. sulfate has a -2 charge. Okay, and the mass of this is 174 grams per mole. Okay, and last one, ammonium is a polyatomic ion, so it's phosphate. Ammonium has a +1 charge. Phosphate has a -3 charge. Okay, so 1 phosphate, 3 ammoniums, 149 grams per mole. Okay, so this is, naming's huge, so if you're struggling with the naming, we've got problems. Okay, this table, pretty important. It tells you everything that 1 mole can be. 1 mole can be the formula mass or the molar mass. Okay, 1 mole can also be 6.02 times 10 to the 23rd atoms of that element. And then if it's a compound, it can be 6.02 times 10 to the 23rd particles, molecules, or formula units. So just to kind of remind you, molecules are covalent compounds. Formula units are ionic compounds. All right, so let's do some problems. When we're pulling the molar mass from the periodic table, I do want you to use 2 decimal places, okay? So we're not doing whole numbers anymore. I don't think we did that last year anyways with pre-AP. So you're doing 2 decimals when you're using the periodic table. Okay, and then when it comes to sig figs, we're doing the sig figs from what they gave us, not from the periodic table. Okay, let's go over here and let's do our first one. So they want to know how many moles, so we're looking for moles, are in 18 grams of sugar. So remember, you always start with what you're given. Okay, and in sugar, I'm just going to go ahead and give you this one. You have 180.18 grams. Okay, and that is equal to 1 mole. Okay, so if you notice, my units are canceling. Grams of that sugar, grams here. All I'm left with is moles. Okay, which is, I get 0.0999 moles, but oh, that's right. And I got that because 0.999 moles of sugar. Okay, so my given had 3 sig figs, so my answer has 3 sig figs. Okay, over here, we got 4.5 moles of barium sulfide. They want to know the weight or the grams. So start with what they gave you. And this is barium sulfide. So again, naming, super important. Okay, how are you going to find the molar mass if you don't know the name? Okay, for every 1 mole of barium sulfide, we have 169.40 grams of barium sulfide. Okay, and when I do the math there, I get 762.48, which rounds to 762, okay, because that has 3 sig figs, and that's grams of barium sulfide. 3, how many molecules are there in 28.6 moles of nitrogen gas? So remember, nitrogen, like at room temperature, is a gas. Nitrogen is also a diatomic, Brinkelhoff, okay? Anything that falls in Brinkelhoff is a diatomic, which means it comes in pairs in its room temperature state. So we start with what they gave us, that's 28.6 moles. Okay, and they want to know molecules. Okay, so in 1 mole, Then I have 28 point, oh wait, no, we're not doing mass, we're doing molecules, sorry. 6.02 times 10 to the 23rd molecules of N2. Okay, so when I do that math there, I get 1.72 times, oh, this is getting ugly, times 10 to the 25th, and now molecules of N2, which makes sense because I should have a lot of molecules. Those things aren't very big. Okay, two more. How many moles are in 3.9 times 10 to the 28th molecules of methane? So we want to know moles. They gave us molecules to start. Okay, so I gotta have molecules cancel out. 6.02 times 10 to the 23rd molecules is 1 mole of methane. Okay, so my answer is 6.48 times 10 to the 4th. That's moles of methane. All right, last one. How many atoms of oxygen are in 2.5 moles of oxygen gas? Okay, another diatomic. So it didn't really matter up here with the nitrogen because we were just going moles to molecules, but now it really matters. But that's always something that you should be thinking about, and it should be firing in your head. So 2.5 moles of gas, okay, of O2, and for every 1 mole of O2, I have to double check this, 6.02 times 10 to the 23rd molecules of O2, but it didn't ask for molecules, it asked for atoms. So for every 1, because I need this to cancel out, for every 1 molecule of O2, I have 2 atoms of oxygen. So remember, I'm multiplying across the top, okay, here, multiply, and then I divide by what's on the bottom, but it's just a 1, so that's okay, we don't have to worry about that, and that gives me 3.0 times 10 to the 24th atoms of O. Okay, not too bad. Kind of getting the cobwebs off. All right, now we got two-steppers. So it's been a minute. So remember, molecules are covalent compounds. Formula units are ionic compounds. So first question says, how many molecules are in 100, which that's wrong. So we're talking about sodium chloride, so this should be formula, oh boy. This should be formula unit, because sodium chloride is ionic. Okay, so we want to know formula units in 198.5 grams of sodium chloride. So let's zoom in. So 198.5 grams sodium chloride. Okay, my official grams of sodium chloride is 58.44 grams. Okay, and that's how much is in 1 mole. Okay, and then in 1 mole of sodium chloride, I have 6.02 times 10 to the 23rd formula units. I'm abbreviating, don't laugh. Okay, so when I do that math, so again, we are multiply, and then you divide by this multiplied on the bottom, which is just itself. So when I do that, my answer is 2.045, okay, because my answer, or my given, had 4 sig figs, times 10 to the 24th Fu, or formula units of sodium chloride. Answer. Okay, this next one. How many molecules are in 937 grams of calcium acetate? Oof. All right, so let's get started. So, and that's supposed to be formula units also, because calcium acetate, acetate's a polyatomic ion, and calcium is a metal. Okay, so 937 grams. Okay, gotta have grams on the bottom, so the official mass of this is 158.17 grams. That's equal to 1 mole. Okay, and for every 1 mole, I have 6.02 times 10 to the 23rd Fu. Alright, so doing the math, times, divided by, times. And when I do my math, I get 3.57 times 10 to the 24th Fu. And that is of calcium acetate. Okay, how many grams are in 3.21 times 10 to the 24th molecules of potassium hydroxide? Okay, so start with what they gave you. 3.21 times 10 to the 24th molecules. Oof, that's a long one. 6.02 times 10 to the 23rd molecules in 1 mole. Okay, and they're looking for grams. So in 1 mole, I have 56.13 grams. Okay, so when I do all that math, I get 299, which is right. My right number is sig figs. 299 grams of potassium hydroxide. Okay, I'm gonna do 1 more, and then I will do 12, and then we're probably just gonna stop right there because it gets a little monotonous after a while. But I'll post the answers to these and the one on the next page. How many atoms of aluminum are in 2 moles of aluminum fluoride? Whoa, those are 2 different things. So let's see how we do it. Okay, so start with your 2 moles. And that's of aluminum fluoride. So this is where it helps to write the names of everything so you can kind of keep it straight. So in 1 mole of aluminum fluoride, I have 6.02 times 10 to the 23rd formula units, okay? But I'm working my way to atoms, so I'm not done. In 1 formula unit of aluminum fluoride, I have 1 atom of aluminum. Okay, and that's it, because now I'm in atoms of aluminum. So again, multiply across the top. Don't have to divide by the bottom because it's all ones. So when I do that, I get 1.24 times 10 to the 24th. And that's atoms of aluminum. Okay. Rest of these, 9, 10, 11, pretty straightforward. Atoms is what they're looking for. You have grams of calcium chloride. Okay, they want atoms of chlorine. So very, very similar to what we just did. So you'll have to go grams of calcium chloride, take it to moles. From moles, you can find formula units. And from formula units, you'll have 2 atoms of chlorine because it's calcium chloride. Here, they want to know moles of carbon from molecules of propane. So same kind of thing. You'll start with the molecules of propane, okay, and then you'll have to convert to moles, and then in 1 mole of C3H8, which is propane, you have 3 moles of carbon. So you can say that. You can say that in the formula, I have 3 moles of carbon because that's the subscript. Okay, so here, maybe I'll just write the answers down for you and you can check your work. So here I have 7.101 times 10 to the 24th atoms of chlorine. Woo. Here I have 0.000498 moles of carbon. This one, they want grams of magnesium from molecules of magnesium sulfide. And your answer there should be 22,400, and that's grams of magnesium. All right, this one I want to talk about because I like this problem. How many grams of strontium are in 9.76 molecules of silicon dioxide? So I'll let you stew that one over for a sec. Oh, a light bulb should be going off because, hello, there is no strontium in silicon dioxide, so it's 0. No. Okay, and then this table, I'm not going to work through. I'm going to let you work through, and I'm going to post the answers this afternoon, okay, because it's all the same stuff we just did. So you've got to be able to use moles. It's a huge part of this class, just like naming, okay? Naming, huge, moles, huge. So please, please, please ask if you need help.